everyone, and hope you are having a fabulous time at Kubernetes Community Day Bengaluru so far. Saranya and I are super stoked to be speaking with you all about chaos engineering for cloud native systems. But before we go ahead, it's just fair, really, that we introduce ourselves to you. So, Saranya, why don't you go first and introduce yourself?
Yeah, thank you, Divya. So, hi everyone, this is Sarna, and I am a software engineer at Chaos Native and also one of the contributor to LitmusChaos. Thank you.
Awesome. Hello everyone. I am Divya, and as part of my day job, I am a team lead with HSBC. And probably from the slide that you're seeing on your screen right now, you've deciphered that am a- I'm an avid open source enthusiast. I've contributed for the past 1.5 year to the Kubernetes and LitmusChaos projects in different capacities. And I'm also one of the co-organizers of CNCF student user group, which is owing to my passion project of getting more folks into open source and having them benefit from the community and the learning that we have here. So today, as I mentioned before, we are going to be speaking about chaos engineering for cloud native systems. Now, before we get there, we obviously do need to understand how the situation was before chaos engineering came into the picture, which is where most of us are currently. And then we need to look at why there was a requirement for chaos engineering to come into the picture, what exactly chaos engineering is, and how it can be extended to the cloud native context, some benefits. And thereafter, in the second segment of the presentation, I shall hand it over to Saranya to speak about the various chaos tools and platforms. And since we both work on the LitmusChaos project, she'll be sort of doing a quick deep dive into LitmusChaos as a product with a really cool demo. And towards the end, we be completely remiss if we actually do not lay out what we think is the future roadmap for chaos engineering as a discipline. So that being said, without further ado, let's dive right in. Uh, Before chaos engineering, which is where a lot of us are at even right now, even though chaos engineering is not a very new discipline, so to say. So before chaos engineering was implemented in a lot of organizations and where we are currently, there are customer and service impacting outages. That is something that's there irrespective of whether chaos engineering is there or not, really honest. But when those customer and service impacting outages used to occur, the mean time to resolve or the mean time to recover from such an outage used to be high, because more often than not during such an outage you required SMEs and getting them on the call, or coordinating with them towards recovery was somewhat of a struggle. Not because the processes weren't laid down and you did not have recovery documents in place, but it simply wasn't or isn't a streamlined process altogether. And like the Shaolin monks say, the more you bleed in practice, the less you bleed when you actually have a problem. And I'm paraphrasing it here, but when an actual outage occurs, we weren't really prepared for it if chaos engineering was not something we considered implementing in our piece of infrastructure. And of course, after this outage occurred, there would be what we term as blameless postmortems, but they really are far from being blameless, really, because it's always about finding the root cause, but we tend to target the symptom instead of the actual cause. So these would eventually end up being the burden on your SREs or your infrastructure engineers, as opposed to diving deep inside your particular code base or the way your application is designed. And of course, all of this is sort of fed into, uh, all of this information is gathered from, your monitoring and observability infrastructure. And in the absence of a discipline that sort of streamlines this process, that was really rudimentary. It's just now in the recent past that monitoring, observability, distributed tracing, logging have started gaining a sort of importance towards better recovery processes and towards ensuring that the applications we deliver are highly resilient and highly available. So we can clearly see why there was a need for a discipline, because although we knew what was required, we did not have all of it streamlined in a proper way. And chaos engineering, let's look at what it is. According to principles of chaos.org, chaos engineering is basically just experimenting on your systems towards building confidence among your customers to withstand turbulent conditions in production as and when they occur. Now, how do they do that, and why is this really any different from testing? So, how we do that is via experiments, which is something Saranya is going to demonstrate in the latter half of our presentation. And how is it any different from testing? Which is a very good question, because that's something that I myself struggled with when I started off learning about chaos engineering. So, in testing, you are basically aware of what you are giving as an input and what you get as an output. So if your system is subjected to particular conditions, it should either give you A, B, or C result. And if it doesn't, it is failing the test. I mean, you get the point. Testing is basically a choice, not a choice really, but testing is between uh, the system's input being known as well as the output being known correctly. While experiments don't really have a fixed output, because when you're experimenting, you are just subjecting the system to unstable conditions. You do not know what the outcome of that experiment is going to be. It could be anything, and that is what we are looking to learn more about. Chaos engineering is jumping into the unknown and taking a leap of faith towards understanding your systems better. Now, when we speak about chaos engineering, it's a common myth that a lot of us really believe that chaos engineering is only for cloud native systems. And there's often a question thrown at me when I speak about chaos engineering as to whether chaos engineering is only cloud native. So the answer is no. Chaos engineering is definitely not cloud native, because, as aforementioned, we have experiments done on various systems, and systems really do not have this discrepancy of judging amongst themselves whether they're cloud native or not. It's us humans who give them that context. So chaos engineering can be performed on cloud native and non cloud native systems alike. The only plus one here in terms of cloud native is that the availability of tooling is much more as compared to the others, because as a sector, IT is moving towards the cloud native side of things. So it's just generally evident that chaos engineering tools which would be developed are more catering towards that move, rather than being stuck to the way we used to do things. So you absolutely can have chaos engineering performed on your non-cloud native infrastructure, which is in your own data center. But the only thing is you will have a lot of challenges because of the lack of a lot of associated monitoring and observability tooling. And obviously, if you are trying to do it by yourself, it's going to be a little more difficult because with the available tooling, you are leveraging a lot of associated monitoring and observability tooling. With your own customized scripts or with your own customized tool, you probably might not be able to leverage that. Like if you create something from scratch, it's a little more difficult to actually have anything related to chaos done. So it's not impossible, but yes, doing it by yourself is going to be a problem. And I'm sure Saranya is going to cover some of the available tools in the market, both cloud native, non-cloud native, open source, and proprietary in the section that she is going to take. That being said, I've been waxing about chaos engineering and what it is about and how it can be extended to the cloud native context. But really, when you're talking about something, you need to understand what are the benefits and how it impacts you as someone who's from the application development team or someone who designs applications. So in that case, this slide is a very good maybe overview of how it benefits you. So the very first, impact, and I'm going from top to the bottom, is that because of resilient systems and better processes, your systems aren't going to fail as frequently. They will fail, which is something that is a given, but they are more resilient towards failure. And because you have experimented on them and have learned where their vulnerabilities lie, you are aware of what could possibly go wrong. So you are in a better position to recover from such failures. So when you are in such a good position to recover from failures, you have better MTTR, which also means that customers have to spend less time being frustrated. And obviously, when you have resilient system, that directly correlates to having lesser outages, which is again, pretty good from a customer for a customer, because nobody likes their apps down, right? Then comes the business, because when we look at the business side of things, we are looking at better processes. And when we look at better and more efficient processes, we are definitely looking at efficient incident management. And when we are saving up on so many overheads in terms of outages and coordination and recovery times, we are definitely aiding in the prevention of losses. And last but not the least, technical staff are the most important in this ecosystem, because they are the ones who ensure that all this is working as per requirement. So when your technical staff are happy, be rest assured that all the above two layers are going to be happy as well. Because when we look at chaos engineering being implemented in organizations, we are looking at better and more reliable systems, because during these experiments you will discover what vulnerabilities are there within your systems, and you're able to address them ahead of time. And maybe when an actual outage occurs, you are going to be better prepared towards understanding how to recover from that, which directly correlates to for the technical staff, that they have to not be present 24/7 in case you're a subject matter expert, or even the on-call for that particular application. So that will make sure that your technical staff are able to cater to actual incidents and to effectively prevent them from happening the next time around. So that being said, I think it's time for me to hand over to Saranya to talk about the various tools available in the ecosystem, and maybe walk you all through a quick demo of the LitmusChaos project. Over to you, Saranya. I'll just stop my screen share.
So thank you, Divya. I'll be sharing my screen. Divya, can you stop sharing the screen? Okay. Actually, it is showing disabled. Like you have to enable the screen sharing for non-host participants.
Just a second. Yeah, you should be able to have the screen share right now.
Yeah. Yeah. So hi everyone. So I'll just present it. So as you can see, these are some of the tools that are being used for practicing chaos engineering. Practically, it won't be possible for me to like go through each one of them one by one. So like me being a contributor to Litmus Chaos, so I know I have used it, so I know about it much better. So I'll be talking about it in the upcoming slides. And other than that, we have Chaos Monkey, which has been the earliest one of the earliest chaos engineering toolkit introduced by Netflix, and you can actually go through them and find like according to your requirements. And then like these can be classified into various categories, such as some of them are cloud native, some of them are not, some of them are open source, and some of them are specific to networking or some any other particular platforms. So yeah, so you can just find out your own use case and then get started with it. uh, then then coming to Litmus. Litmus is an open source cloud native chaos engineering toolkit, which provides all those features that Divya has already talked about while explaining the major principles of cloud native chaos engineering. As you can see, it is open source. Then it supports community collaboration. Then we have kept the API and lifecycle management open to maintain actually the transparency, so that user can know what are the APIs and how are they being managed. So yeah, so we have the GitOps enabled, so that like Git being a very like primary tool for developers, like integrating it with Litmus has proven to be very useful. Then we have open observability. So like as of now, we are using Prometheus and Grafana, but since it is open, you can bring your own observability tool and add it to your solution. So other than that, Litmus is a CNCF sandbox project, and we have been getting a lot of attractions lately. So we have around 56 chaos experiments with more than 100K installations. And we believe that in the upcoming years, Litmus is going to be the go-to tool or platform for practicing chaos engineering to look forward to. Yeah. So let's get started how we can start inducing chaos in a system. So we can actually install Litmus using Helm chart, and we can to induce chaos we can either use custom templates, or we can induce our own custom workflows or chaos using either by using public chaos hub, which contains actually all the experiments that like it is actually public, and we can even have our private chaos hub and connect it, use it within Litmus. So I'll just give a demo of how we can induce chaos. But like let me tell you, there are actually two ways. So we can either use induce it by using terminal, or we can use Litmus portal, which is actually a web UI. Like it provides it provides better visualizations of workflow, and it comes with a lot of features, a lot of other features such as teaming, analytics, etc. So I'll be giving a demo of Litmus portal itself. So without much delay, let's get started. Yeah, so as you can see, I am running it on my own Minikube, but you can use any other platform such as like Kind, K3s, or any other public cloud. So I have applied the latest Litmus 2 beta YAML. Then I'm as it is visible, the pods are up and running. This is the front end pod, this is the server pod, and this is the MongoDB pod. And if I I'm taking the port number of front-end service and the Minikube IP, I should be able to run. I'm able to run Litmus portal. So yeah, so this is the login screen of Litmus portal. And by default, the credentials will be like the username is admin and the password is Litmus. So once I log in, a default project would be created for me, and I'll be asked, so this is the onboarding screen where I'll be asked to change my password. So for now, I'll be keeping it 123. So once I have onboarded, so this is the main homepage where, as you can see, this like here, this is the default project that has been created for us. And if you are part of any other project, you should be able to see them here. And this is the user level details, and you can like edit your profile here by coming to my accounts on Litmus settings, and you can edit your details. Then if you're an admin, you should be able to create new users. So once the users are created, I should be able to invite people to my own project. So currently we are supporting just a viewer and editor, like a viewer and editor role. And so this is the teaming section actually, where you can change the project, where you'll be getting the list of members, the invitation status, any active invitations, or any active project that you have been a part of. And other than that, we have the GitOps section. And yeah, so this is the analytics section, where you can see the analytics of the workflow that you have created. And this is the agent section. So agent is like when you install chaos, self agent gets created by default, and the chaos operator gets installed here. And we should be able to run any chaos experiments on this target agent. So I can actually connect multiple agents, external agent, by following this procedure. But for now, I'll be using my own self agent. So then comes the chaos hub, as I have already mentioned. So this contains all the experiments that are available publicly for use. Then comes the workflow page. So a workflow is a single unit where like it contains a lot, like several experiments which can be sequenced parallelly or serially, or a combination of both according to our own requirements. And we can see if we have scheduled any workflow, so we can see any all the details related to that particular workflow, which which have already run or which are currently running. And then this is the schedule page, where if I have scheduled any workflow, I should be able to see all the details regarding that. So I'll go ahead and schedule a workflow. So first of all, I need to choose the target agent. So this is the self agent for now. Yeah, so while choosing workflow, I'll be asked 4 options. So first one is if like choose any predefined chaos workflow template. And if you have any existing workflow, you can actually clone it and use it. Then you have the option to choose experiments from my hub. So for now, since I have just the chaos hub, I can just choose it and go ahead. And the fourth option is, if you have any workflow YAML, you can just drag and drop and get started with it. So for now, I'll be choosing potato head chaos, the predefined workflow. And then if I hit next, so this is the page where you can change any descriptions or like according to your own requirements. Then yeah, so this is the actual visualization of a workflow, how the experiments will take place. So you can actually edit the sequence if you want, like by just dragging and dropping. But I'll keep it as it is for now. Yeah. So if I hit next, so I can tune the experiments of my workflow according to my own requirements. Then once this is done, so I'll be asked to schedule the workflow. So we have 2 options. Either we can schedule it right now, or we can have a recurring schedule. So I'll go with option 1 for now. So yeah, so this is the like summary page of the workflow that we are going to schedule. And if you want to do any changes, so you can just go back and make the changes. So once I hit the finish button, workflow should get created, and we can, yeah, so this, we are in the browse workflow. We can get all the details here. As you can see, the workflow is currently running. So if I click on this particular workflow, so this is the graph view of how the workflow is running. So this is like, as you can see, it is running right now, and this the application installation is pending. So if you click on each of the node, you can get all the details regarding that, related to that. And yeah, so here like it is pending right now, so you can get the logs here. So this is the graph view, and we also have the table view, where you can get all the details related to the current workflow. So yeah, so this is the schedules page, where like since I've scheduled one, so I'll be getting all the details regarding that particular schedule here. So yeah, so this was a very brief demo of how we can like induce chaos in our own targets. So moving ahead, Yeah, so Litmus in a nutshell. So in a nutshell, we have the central Litmus portal, and all we need to do is just like pick up any predefined workflow or any custom workflow and run it against a target agent. And as I have already mentioned, we can have multiple agents. So once the experiments are run, the chaos metrics are exported to Prometheus, and the chaos analytics are pushed back to Litmus portal. So we can like monitor the chaos results using Prometheus by like with the help of chaos interleaved analytics. Yeah, so like Litmus can also be run on or used on like bare metal devices or bare metal environment or any other public cloud such as AWS, Azure, GCP, etc. Then yeah, future roadmap. So like it is pretty evident that chaos engineering is one of the fastest growing technology in 2021. So like as the number of industries adopting chaos engineering increases, these chaos engineering tools need to be smart too. So it is very likely that these tools would be integrated with machine learning tools or artificial intelligence, so that they can help automating the analysis activities, and then they can also help in improvising the monitoring of applications when the experiments are being run. And who knows, like they might be even able to find out or detect some threats or faults that have gone unnoticed before. So that's all from our side. I We hope that you enjoyed this session. Thank you.